Hi students, today we will learn about projectiles. In this picture, you can see a boy is throwing a ball. When this ball is thrown obliquely, it follows a curved path. The ball falls down due to the force of gravity. Projectile motion is the motion of an object thrown or projected into the air subject to the acceleration due to gravity. The only force which we consider here is the force of gravity. This doesn't mean that it is not having any other force. They are minimum when compared with this force of gravity. Therefore, you are neglecting the air resistance, etc. The object which is thrown is known as projectile and the path is called as trajectory. This path is a parabola. A baseball batted or thrown is an example for the projectile. Projectile motion of any object is a parabola. See, this projectile motion is two-dimensional, because both the horizontal and the vertical positions changes with the time. If the ball is thrown with an initial velocity u, you will resolve this velocity component into its horizontal component and vertical component. This horizontal velocity remains constant throughout this motion, whereas this vertical component is changing. What will be the reason for that? This is because the gravitational force acts vertically downwards. This is the direction for the G. When a ball is thrown upwards, the vertical velocity component is shown here. When it reaches at the maximum height, this vertical velocity component becomes 0 because G is acting in the opposite direction. And then when the ball starts falling down from this maximum height position, this velocity increases. It is in the same direction as that of G. Here the ball is moving in the opposite direction of G. Therefore, here this velocity decreases. Here the velocity increases. This is the point where the ball reaches the maximum height, where the vertical component of the velocity becomes 0. G will not act in this direction, therefore it remains the same everywhere. If the body is projected with a velocity v, that v can be resolved into its horizontal component and vertical component. If the body is thrown with an angle theta with the horizontal, this horizontal component will be v cos theta. The side which is adjacent to theta will be always the cos component, and the vertical component will be v sin theta. The horizontal force acting on the object tends to move the object horizontally, and the gravitational force acting on the object tends to move the object downwards. The combination of this horizontal force and the gravitational force tends to move the object in a parabolic path. Range of a projectile is the distance between the point of projection and the point where it reaches the ground. This distance is known as a range of the projectile. We know distance is equal to velocity into time. In our previous class, we learned about kinematics equations or SWAT equations. We can use those equations in projectile motions. In this class, we learn about projectile motion. If a body is thrown upwards with an angle theta with the horizontal, it follows a parabolic path. This type of motion is called projectile motion, and the object or the body which is thrown is called a projectile. Since the object is thrown at an angle, it can be resolved into its horizontal component and vertical component. If this angle is theta, this will be u cos theta and this will be u sin theta. If the velocity is represented by v instead of u, then this component will be v cos theta and this component will be v sin theta. The only force which we consider here is the force of gravity. Always remember that this vertical component and the horizontal component are independent of each other. That is, they do not affect each other. You can use the SWAT equations to find the numericals asked, such as velocity, acceleration, time, etc. Please note that the acceleration will be the acceleration due to gravity. G value is 9.81 meter per second squared. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.